Have you ever turned on a tap in a tall apartment building and wondered how the water managed to climb dozens of floors before reaching your sink? It seems almost effortless. There are no visible buckets, no giant hoses running up the side of the building, and no one manually pumping water every time you take a shower. So how does clean water travel hundreds of feet upward, seemingly defying gravity? And why doesn't the water pressure stay the same no matter which floor you're on? Today, we will uncover the hidden journey every drop of water takes before it reaches the highest apartments. Right here on History of Simple Things. Supplying water to buildings has been a challenge for thousands of years. Ancient civilizations such as the Romans built impressive aqueducts to carry fresh water over long distances using gravity alone. Their system worked well because the water source was usually located at a higher elevation than the cities it served. But as cities grew upward instead of outward, gravity alone was no longer enough. By the late 19th and early 20th centuries, skyscrapers began changing city skylines, and engineers faced a new problem: getting clean water safely to people living and working many floors above the ground. The journey actually begins far away from the building itself. Most cities collect water from rivers, lakes, reservoirs, or underground aquifers. Before anyone drinks it, the water passes through treatment plants where dirt, bacteria, and harmful chemicals are removed. Once cleaned, it enters a network of underground pipes known as the municipal water system. These pipes are already under pressure created by pumps at water facilities or by reservoirs located on high ground. That pressure is usually enough to supply houses and shorter buildings without any extra help. However, there's a limit to how high that pressure can push water. Water pressure decreases as it rises because gravity pulls against it. Engineers often describe this using the idea of head, which is simply the height water must climb. Every meter upward slightly reduces the available pressure. If city water systems tried to maintain enough pressure for the tallest skyscrapers directly, the pressure at street level would become dangerously high, increasing the risk of burst pipes and damaged plumbing in lower buildings. That's why taller buildings need their own systems. When city water enters a high-rise, it often flows first into a storage tank located in the basement or lower levels. Powerful electric pumps then take over, pushing the water upward through vertical pipes called risers. But instead of pumping directly to every tap all the time, many buildings send the water to another storage tank located near or on the roof. At first, putting a huge tank on top of a building might seem backwards. Why pump water all the way to the roof just to let it flow back down again? The answer is reliability. Once the tank is full, gravity becomes your best helper. Water naturally flows downward, creating steady pressure throughout the building without requiring the pumps to run every second. Even if electricity briefly goes out or the pumps need maintenance, the rooftop tank can continue supplying water for a period of time. That's one reason rooftop water tanks have been common features of city skylines for more than a century. New York City is perhaps the most famous example. Thousands of wooden water towers still sit atop its buildings today. Many people assume they're old-fashioned decorations, but they remain practical. The city's water mains generally provide enough pressure for only the lower floors of taller buildings. Rooftop tanks allow gravity to deliver water evenly, while reducing wear on pumps and plumbing. Surprisingly, the wooden tanks last for decades because the wood stays swollen when constantly filled with water, helping prevent leaks. Modern skyscrapers, however, often use more advanced designs. Extremely tall buildings are usually divided into several pressure zones. Instead of relying on one giant pump or a single rooftop tank, different groups of floors have separate pumps, storage tanks, and pressure controls. This prevents excessive pressure on the lower levels while ensuring that people on the highest floors still get a comfortable shower and reliable drinking water. Another clever device found inside many buildings is the pressure-reducing valve. Without it, water flowing downward from a high tank could become too forceful on the lower floors. These valves automatically lower the pressure to safe levels, protecting pipes, washing machines, toilets, and taps from unnecessary strain. It's a simple invention that quietly prevents expensive plumbing problems every day. As buildings continue reaching greater heights, water systems keep evolving. Some modern towers use computer-controlled pumps that constantly adjust their speed based on demand. Early in the morning, when many residents are showering, the pumps work harder. Late at night, they slow down to save electricity. These variable speed systems improve energy efficiency while delivering more consistent water pressure throughout the building. The next time you visit the top floor of a hotel, apartment, or office building and turn on the tap, you'll know that every drop has completed an incredible journey. It traveled from a distant source, was carefully cleaned, pushed through miles of pipes, lifted high above the ground by powerful pumps, and finally allowed gravity to do the last part of the work. It's one of those everyday engineering marvels that's hidden in plain sight, a reminder that even something as ordinary as running water has an extraordinary story behind it. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.